Welcome to Let's Do Revision official YouTube platform. So in this video, we're just going to answer Science Paper 2, that is 2024 GCE, and we are going to focus just on Section B. And I guess by this point, you've subscribed to this YouTube channel. If you've not done so, consider doing so that you do not miss out the updates. So here is the first question that we are going to answer, and as you know, Section B gives you 45 marks in an exam, and you're asked to answer all the questions. And if you're writing exams in November, I guess your preparations are going okay. So the question reads, a box of chemicals in the laboratory has the following symbols attached to it. The first question is, describe the nature of chemicals in the box related to the symbol. So in the case you are not able to see the symbol clearly, what is here is just a frame. Okay? Now, what does it mean when you see chemicals in the laboratory with such a symbol? This means that, or they are just telling you that the chemicals are highly flammable. So that means that chemicals are highly flammable. Then write a laboratory rule that is observed when handling such chemicals. Write a laboratory rule that is observed when handling such chemicals. Okay, so one of the laboratory rules that you follow is that they must be put under or stored under low temperature. Immediately you store them under high temperature, there's a high chance that they might catch fire. Then also do not shake such chemicals. So do not shake such chemicals, as it can agitate them, which could result into catching fire. Then question B, when a bottle of ammonia is opened, within a few minutes its smell spreads throughout the laboratory. Name the process responsible for even distribution or spreading of the smell of ammonia solution. Okay, so the process responsible for this is diffusion. As you know, diffusion is a movement of particles from region of high concentration, or where they are highly concentrated, to a region where they are in low concentration across the concentration gradient. And you need to know also the factors that affect diffusion. Then the question, that is question 2 of B, describe the process responsible for the even distribution or spreading of the smell of ammonia. So you are describing now diffusion. So in this case you can say ammonia particles moving from the region where, or from the region of high concentration to the region of low concentration. Randomly colliding with each other and air molecules or particles. So to describe the process or responsible for the movement for the even spreading of ammonia. So ammonia particles moving from the region of high concentration to the region of lower concentration, randomly colliding with each other, and also the air particles. Or you can say the ammonia particles spread from the region of high concentration to the region of low concentration across the concentration gradient until the particles are evenly distributed. Okay. Then relate to the evidence which the process named in B1, that is diffusion, provides to the kinetic theory of matter, relate the evidence which the process named in B1 provides to the kinetic theory of matter. So matter, it shows that matter contain small particles, that are in continual motion, or the ones that are randomly moving or always in motion. So that is the evidence that is the evidence it provides to the kinetic theory of matter. Then now we go to the second question. The following diagram shows the piece of apparatus in the laboratory. So as you can see, what piece of apparatus is this? So if you are unable to identify this apparatus, then this is the time that you need to go back to your notes and study. And of course, you need to know all the glassware that are found in the laboratory. Okay, you don't know the one that might be picked. It's not that every time you're going to find this one. There are quite a number. You need to know them before the exams. Name the piece of apparatus shown above. So the piece of apparatus is called the separating. This is the separating funnel. So this is the separating funnel. Identify two properties of the mixture separated by the piece of apparatus. So it separates immiscible liquids, which means liquids that cannot mix completely. Suggest the names of two liquids that can be separated by the piece of apparatus in the above. So what are the two immiscible liquids? So you can talk of water and oils. Okay, it can be cooking oil. So these are two immiscible liquids. Suggest two precautions that need to be taken to separate the mixture in B2. So what are the precautions that should be taken to separate immiscible liquids? So ensure that the tap is closed before filling in the funnel. So ensure that this tap is closed. So that is one of the precautions. So 1, ensure the tap is closed before filling the funnel. Okay, before filling the funnel. Then ensure the funnel is clean, which means properly cleaned and dry. Okay, so we've answered this question. We go to the third question, that is B3. The diagram below shows the electron configuration of the ion of element M. Then now draw the atomic structure and write the electronic configuration of the atom of M. Okay, draw the electronic structure and write the electronic configuration of the neutral atom of M. So neutral atom of M, the atomic structure. First we are going to look at the ion. The ion has how many shells? 1, 2, 3. 3 shells. And in the outermost shell, it has how many? It is full. Then they are telling us it lost 2. So electron configuration, it is going to be, let us put M. So in the first shell 2, in the second is 8, second is 8, and the third one, there are 2. This is because before the reaction. So now, how can we draw now the structure? So 20 protons, 20 neutrons. Okay, like this. Then of course the first shell has how many? 2. Then the second shell, I'll put the second shell. So please be able to draw the nice drawing. So the second shell has how many? 8. You pair them like that. You pair them like that. Then of course the third shell also has how many? 8. Remember, we are drawing the neutral before a reaction. Okay, before the loss. Okay, then the last shell now has how many? 2 electrons. So you can put like that. So those are the ones that were lost. So this is the structure that we needed. And of course the configuration is 2, 8, 8 and 2. Okay, then so we've answered this question. Give, so the configuration we can put it here, 2 8 8 and 2. Give the name, group and the period of the element M. So to get the name of this one, the period, we count number of shells. So 1 2 3 4. So it is from period D 4. So period is period D 4. Okay, then group number, we look at the number of electron in the outermost shell. So it's from group 2. Give the name, group and the period. So it's from group 2, then period 4. What is the name? The name, if you look at this is the calcium. Okay, the periodic table is given in an exam, so you do not have to worry about this one. The periodic table is given. Then compare the reactivity of M and an ion of M. So we are comparing the reactivity of M and M2. Now look at this. When it undergo an atom, an element or atoms of an element undergo a reaction or lose or gain electrons for them to gain stability. So the moment that it loses electron, then it becomes more like group 8 element. They become non-reactive. So if we were to look at which one is reactive, M is more reactive than the ion, and because M is unstable. Okay, so M is more reactive than the ion, so M is more reactive than, so compare the reactivity of an atom of M and an ion of N. So you can say M is more reactive, M is more reactive than M ion. Then you can give the reason, because M is unstable, M is unstable, whereas or while M ion is stable. M ion is stable because it has a required number, because it has a required number of electrons, in the outermost shell. So that is the answer to this one. Then we move to the other question, that is B4. Salts are a substance that have many methods of preparation. Salts are substances that have many methods of preparation. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. Which reactant should be in excess? Which reactant should be in excess? Okay. So salt are substances that have many methods of preparation. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. So which reactant should be in excess? So the reactant that should be in excess, so substance X should be in excess. Okay, why should the named reactant in A1 be in excess? So that all the acid are completely used up. So that all the acid moles are completely reacted, okay, or used up. Suggest the suitable reactant as substance X. Suggest the suitable reactant. Now look at this. The salt that was produced was iron chloride. Chloride is coming from hydrochloric acid, and of course there's iron here. So the suitable is iron metal, okay, which is just Fe. Okay. Write the balanced chemical equation for the reaction between substance X suggested in B1 and dilute hydrochloric acid. So iron plus HCl, what is produced is a salt, which is iron chloride, which is iron chloride. This is iron 2, so iron chloride plus hydrogen gas. Generally, you know that when a metal reacts with acid, it forms a salt and hydrogen gas. To balance this, we just put a 2 in front of hydrochloric acid. This is the balanced equation. And the state symbols, this is solid, this is aqueous, and that is a gas. Okay? So that is what we needed to write on this one. Do we still have another question? At all. So that is the end of this question. Then B5, 1.5 gram of sodium hydroxide was reacted with the dilute sulfuric acid according to the equation. So you're given the equation here. We are told balance the equation. Okay, balance the given equation. So how do we balance this given equation? So let us rewrite the equation. So NaO, sodium hydroxide, which is aqueous, react with sulfuric acid, which is also aqueous. In this case, we are going to form sodium chloride or sodium sulfate and water. Okay, so due to space, I will not write the state symbols there. Then to balance this equation, we just need to put a 2 here. Okay, and a 2 in front of water right there. Check if it is balanced. So this side we have oxygen. Oxygen we have 6, that is 2 and 4. So 6. 4 and 2, 6. Then hydrogen we have 4. Hydrogen this side we have 2, then plus 2, that is 4. Sulfur we have 1, sulfur we have 1. Sodium we have 2, sodium 2. So this is the balanced equation. I guess there's no one with a problem when it comes to balancing the equations. Then B, that is B1. Use the balanced chemical equation to calculate the mass of sodium sulfate formed. Okay, to calculate the mass of sodium sulfate formed. So what are we going to do? So in this case, we are going to form the ratio of sodium hydroxide to sodium sulfate. Okay, then now, since we are calculating the mass, we are going to use mass to mass. And in this mass to mass, we just find the molar mass of this one. We treat it as mass with the units of mass given in the equation, in the question, which is gram. So what is the molar mass of sodium? Sodium is 23 plus 16 plus 1. That is 80, I guess. Is it able to give us 80? Is it 80? There's a 2 in front. Okay, there's a 2 in front. So there's a 2 in front. Sodium itself, that is 23 plus 16, should be able to give us 49 plus 140. And 40 times 2 is 8. Just confirm on that part. Then sodium sulfate should be able to give us 142. Then of course, what about 10.5 gram? Is giving us is the one that we do not know. So we are using the ratio of mass to mass. So what it means here is that 80 grams of sodium hydroxide is reacted with acid to produce 142 gram of sodium sulfate. What about if 10.5? Some of you might ask, where is 10.5 coming from? It is coming from there. Where is 80 coming from? I just found the molar mass of sodium, but since there are 2, I've multiplied the number that I found with 2, giving me 80. Sodium hydroxide 40, multiply 2, 80. Then the other side also, sodium, that is 46. 46 plus sulfur, which is 32, plus oxygen, which is that is 16, which gives us 64. If you add that, should be able to give you 142. Okay. Then now if you do the cross multiplication to find x here, you are going to have x 80 gram is equals to 142 gram multiplied by 10.5 gram. Divide 80, divide 80. Then x is equals to, for me I'm able to find 18.64 gram of sodium sulfate. What are you able to find? So that is how you simply find the mass. Okay, what type of reaction is involved in the equation? What type of reaction is involved in the equation? This is what we call a neutralization reaction. Neutral compounds are formed, that is salt and water. So acid-base reaction are neutralization reaction. Okay, let us look at B6. Element A is in group 1 of the periodic table. So we are given that element A is in group 1 of the periodic table. Another element N is in group 7. Write one property of the compound formed when A and N react. Now, the one that is in group 1, automatically you know that is a metal. Then the one that is in group 7 is non-metal. So in other words, when a non-metal reacts with a metal, it forms ionic compound. The question is, what is the characteristic of an ionic compound? So it conducts electricity. So it conducts electricity in molten state. So conduct electricity in molten state. Also high boiling point and melting point. You can talk of also other properties. Okay. What type of bonding exists in a compound formed when two elements react? What type of bonding? So this is ionic bonding or electrovalent bonding. Electrovalent bonding. Okay. How does the reactivity of elements in group 1 differ from that of elements in group 7? How does it differ? So in group 1, reactivity, so we can say in group 1, reactivity increases down the group. So as you go down the group, reactivity increases. Whereas in group 7, reactivity increases going up the group. In other words, they're asking you, how is the reactivity in metals and non-metals different? So in metals, starting with the first one, going down the group, reactivity increases, which means the one that is at the bottom is the most reactive. But also in non-metals is different. The one on top is the one that is reactive. The one at the bottom is less reactive. So if we were to follow them, starting from down, going up, reactivity is decreasing. So the most reactive in group 7, which are halogens, is fluorine. Then going down, reactivity decreases. Okay, then question 7, metallic bonding accounts for most of the physical properties of metals. With reference to metallic bonding, explain why most metals have high melting points. Okay, so we can say due to strong electrostatic, so due to strong electrostatic force of attraction, due to strong electrostatic force of attraction between positively charged ions and negatively charged electrons. Okay, so a lot of energy is required to overcome the forces of attraction between the ions. So that accounts for the high melting points in metallic bonding. Draw, that is on question B. We are on question B. Draw a diagram to show metallic bonding in zinc. So metallic bonding occurs within a metal. So we are going to say this is a zinc metal or a piece of metal. Then zinc, you know that it has a valence of 2. So we are going to say this is zinc and it has lost 2 electrons. Then of course that electrons become delocalized. So also that is zinc. Then that is zinc. Then okay, we have zinc. Then we have zinc. We have zinc. So you can draw something like that. Electrons, you can just put E with negative if you want. So electrons are delocalized. The electrons that are lost are delocalized or they are freely moving. You can even put a key where you say E to represent what? Electrons. Then Z, then 2 represent zinc ion. Okay. Question C, Elena carried out the following experiment in In experiment 1, 5 grams of powdered zinc, and in experiment 2, 5 grams of granule of zinc were each reacted with a volume of dilute hydrochloric acid or same volume of or equal volume of hydrochloric acid with the same concentration for 15 seconds. The reactions were not completed at 15 seconds. In which experiment would a large volume of hydrogen produce? Give a reason why. So this one, they are just asking you in which reaction of the two will the reaction be faster. So we have powdered zinc and granules. So surface area is one of the factors that affect rate of chemical reaction, and the smaller the particles, the higher the surface area. They will react, and of course the products will be formed at a faster rate. So in this case, in experiment 1, okay, so give in experiment, so we're saying experimenting, so I'm going to say experimenting 1, then give a reason. So we can say powdered zinc provides a large surface area for the chemical reaction than granule zinc. So let me hear from you how you can explain this one as well. Then question 2, what would be the effect of reducing the temperature of the acid? What would be the effect of reducing the temperature of the acid in the reaction? So now, temperature is one of the factors that affect rate of chemical reaction. As you increase the temperature, rate of reaction also increases. But as you decrease it, it also reduces or it slows. And you need to know the explanation in terms of kinetic theory behind that. Okay, to give you a clue, it has to do with the excitation of the particles, which makes them to collide more often, and hence increasing the chance of forming productive collision or colliding. So here what we can write is that the rate of chemical reaction, the rate of chemical reaction will slow, the rate of reaction will be slow. And this is because chances of reacting particles to collide reduces. As simple as that. Okay, so we have B8 here. The following diagram shows laboratory preparation of gas and its correction. Identify one error set in the diagram shown. Identify one error in the setup in the diagram shown. So one of the errors is that the funnel is not dipped into the reacting substance. So this funnel should be dipped into the reacting substance. Then gas X, what is gas X? So looking at what is here, granules of metal Y, hydrochloric acid. So the gas here is hydrogen gas. Okay, so hydrogen gas. Predict what would be observed if metal Y is replaced with the copper. The reaction will not occur. Then with reference to the air pollution, compare the uses of ethanol and diesel. So if we are to compare the reaction between the two, the air pollution between the two, you find that ethanol produces less pollutant compared to diesel. So we can say when ethanol burns produces less carbon dioxide or carbon monoxide compared to diesel. Therefore, diesel fuel pollutes the environment more than ethanol. I guess you've gotten that. So when ethanol burns produces less carbon dioxide or carbon monoxide compared to diesel fuels, and therefore diesel fuel pollutes the environment more than ethanol. So that is what you need to write on this one. Okay, so we've come to the end of the presentation. So please, like I emphasized from the first, if you've not subscribed to this YouTube channel, consider doing so. And if you're writing the exams, just some days to come, all the best. And I hope you find this video useful. Okay, so if you want to get also the study materials, that is the booklets that we produce, past papers compiled booklets, and also if you need some pamphlets, you can still get in touch.